Hello everyone, welcome to our YouTube channel. This video will explain how to use ping utility and tell you how to set up Wireshark filter to capture ping traffic. I hope you have already watched our Wireshark installation video prior to watching this. Ping is a system utility which is used to see remote computer network connection status. Ping uses the ICMP Internet Control Message Protocol as a echo function. Okay, let's fire up a couple of command prompts first. Let's fire up the Wireshark as well and turn on the capture as well. Now if you go to your command prompt and type ping and hit enter, here you will see all the options available for you, which I will talk in a minute. Let's do some simple ping to myself. This is a simple ping to my machine. In this ping you will see ICMP request is generated and ICMP reply is coming back. The payload for default request echo request is 32 byte, here you can see, and time is a return time or round trip time for each echo, which include request and reply. And TTL is a time to leave, is a number which is used to track the number of hops or route of packet captured across the network. Let's talk about your options. As you already might know, this continuous ping -T option, or you can press /T. That gives you a continuous ping. It will generate a continuous echo request, and as you can see, replies are coming back as well. To break this, you have to press Ctrl+C or Ctrl+break. Second option is -I. This gives a reverse lookup for any IP address available. Let me do one of the IP address reverse lookup. If I do this, you can see the name is resolved against this IP address. This is useful if you want to resolve any host name for that particular IP address. Third option is count option. By default, ping is generated, or ICMP echo request is generated 4 times by default, but we can modify this option by keeping, say, press N. Say I want to do 5 echo requests. Let's do 5. So you can modify this as per your requirement. Next option is -L. This option is to modify your payload, your size. By default, payload is 32 and it can go up to 65,527 something. Let me modify this -L. Most of the time people say we can generating a 1 byte ping or echo request. So here you can see I'm generating a 1 byte payload. But my question is, why we need even 1 byte payload? We can do, or we can achieve our purpose by keeping payload as a 0. As you can see, echo request is generated and I am receiving the reply as well. Let's see more these bytes thing or payload things in Wireshark. Okay, let me generate again with the 1 byte. This is a self. Let me do my router. As you can see, I send 4 requests. Here you can see I send 4 requests and I receive 4 reply. I want to capture this 1 byte thing. Before talking to this, let's talk about how this ICMP header and IP header and a whole packet is captured. If you look at my notes, it will show you this portion is a payload data that is equal to this 1 byte here, and ICMP header is a 8 byte, 32 bytes if we have a IP header, and 14 byte we have a MAC address header. If we add up all this header, that will become 42, and we have 1 byte of payload, so that become 43. So if I generate 0 payload, that should be equal to the 42 byte of this length. As you can see, I'm capturing only 42 bytes length here, and that is just the header to achieve my ping purpose. I don't need to send any payload here. So for any testing point of view, you can just generate any ping with 0 payload. Header should be enough. Okay, next option is the fragmentation. Before talking to fragmentation, let's see what's my default Mtu size on my machine. To do that, there's a command netshell interface IPv4 show sub interfaces. I think, yeah, okay. By typing this command, I can see what's my default Mtu size. Here you can see for the Wi-Fi, my default Mtu size is 1500. But this Mtu size is again includes all of my header, all of these headers. So if I take out, if I do any ping, say let's do ping with to some public IP address -f -l 1500, say let's say Yahoo. If respond, I don't believe it will respond to this. This is saying fragmentation needs to be done. As you can see, default size was 1500, that's include this header. So if I take out this header, 1500 minus 20 and minus side 28, so that will become nearly 1472. Now you can see this fragmentation is done with this size. Now if we capture the same thing in the Wireshark, let's say echo request and IC intent packet fragmentation. As you see, by putting this, we can say we don't need to fragment, and this bit is will set to the 1. So once this bit is set to 1, that means do not fragment this packet anymore. So in normal network, if you have multiple firewalls or multiple devices in the middle, you can check what's the minimum fragmentation size, and you can keep dropping this number unless you get the ping reply. Say just drop to another one, so feel replying. So this is how you check the Mtu size end to end on your path. Even if I increase from 72 to 73, it will not add, because it will add extra headers. See, we need fragmentation on top of that. Okay, let's see what's next. Next is the Ttl time. Ttl time is time to leave. It is a number that is used to track the number of hops. Let's see, symbol is I. Let's see, I will drop to 5 Ttl. Yahoo must be far away from my machine. Let's think it is 5. If it is not typed, this should expire. As you can see, this Ttl is expired because I have set my Ttl up to the 5 hops maximum. It means Yahoo server is far away from me, more than 5 server. Let's make it double. This time is trying to do something. So this hop probably must be within 10 hops. Okay, let's do normal ping first. Here we can see Ttl setup is 46. So if we modify TTL say 50, so we can see now replying is coming back. And if we look at the Wireshark as well, so here you can see TTL time to live was 50, which I set up here. Okay, now next option is type of services. This option will set type of service header value in your echo message. By default value is 0. Probably I can't show you much on this one because I'm not running any QoS in my network, but there is a command like -l for to set the payload byte, and if you do -b30, you can set up some TOS value in your network to check what kind of TOS value is happening in your network. If you want to look at the Wireshark of this will equal to your differential DSCP values. And if you want to see more what kind of value I'm talking about, as you can see, TOS value for the normal traffic is 0x000 TOS value, and that should be coming here 0x00. That means I'm not running any QoS in my network, and this is normal traffic for me. Okay, let's talk about next option. Record route for the hop count. This option specifies the record route option in the IP header, which is used to record the path taken by the echo request and reply coming back. Let's see if I set a route to C. These are the manipulation commands which might not work in normal scenario, but we should be able to capture something. I want to capture the 5 routes that is going through. As I'm not able to manipulate anything, let's see what's happening in the Wireshark. If I look at this option, and there are some option field here, record routes. So if I click on this, now I can see 1 2 3 4 5. These are the empty routes because I was not able to manipulate any routes throughout the internet. So but in your local scenario or local network, you should be able to manipulate these routes. Let's talk about next option, which is timestamp. Same as this. These are the manipulation commands. We will see if we can do any manipulations, but should not be able to do on the internet cloud. So in the previous capture, you say we can say we have some timestamp come up with a 0 timestamp value because we are not manipulating anything. Further option we have -j. This option is also available if you have multiple routes to go to see multiple destination. For example, you want to choose, it's called a loose route. You just put a particular optional destination routes that it should follow. The syntax for this will be like this. So if you want to go to this destination 10.009.221, and you have to go by either this or this IP address. So you can keep a list of IP address up to the 9 where you want to send your packet. These are the optional routes. So your packet can go through any of these IP addresses. Same thing, there is another option called host list. When we specify the host list, that means it has to be specific. This packet must travel through through those hosts that we specify in our list, something like this. So this packet should move by this and this. If this is right network topology, then you should get some results over here. Further option is timeout. As you can see on my screen, some timeout is happening. By default, timeout is 4000 millisecond or 4 second. We can update this. So let's say I want to reduce for Yahoo reply up to 1 millisecond. So what will happen? Before, it will wait for 1 second before it giving you any timeout. As we can see, Yahoo is replying in a second, so we are not getting any timeout. So let me drop down to this. So we can see time is 3:05. Let's make it 10, and hopefully this is a fraction of second, and Yahoo should not be able to reply in this. So now we are getting the timeout, some timeouts. So this is how you can manipulate your timeout settings for your reply. Basically, it will wait for, it is a timer, it will wait for how long you want to wait for your reply. Other options are -R. This is, I believe, is only for IPv6. Yes, I'm not using. Source address, I can specify a source address which should be used to ping. Let's do by default L0. I want to use my source IP address with -S 10.10.10.47. You can specify a particular interface of your machine if you have multiple interface or IP address. Okay, rest option are not much relevant here, or I have not tested much. Let's go back to your Wireshark filter now. So we have captured lots of ICMP traffic. So first traffic, for first command, I will prefer to always use ICMP. When you use ICMP, it will show you all the ICMP packets. So if you want to see echo replies, okay, request. So by default, okay, before showing to you, let me share you some more information about. Okay, if you look at my screen, these are the ICMP protocol messages on the type field. There are lots of fields available, but most in general we use ICMP echo, that is type 8, ICMP reply type 8, and you will might able to see destination unreachable type 3. There are lots of other messages available as well. So here we can see type 8. As we see here, type 8 is a echo request. To set a filter, right click here, apply as a filter, and select. Here you can see, I will see all the requests generated, echo requests from all the echo requests captured in this filter. If you want to add, if you have huge log of traffic, you can set a source as well. Double click on this and say select. Sorry, I did the wrong way. Let's go there, apply, and add. So this will show you all ICMP requests sent by this source. So you can say you are generating these how many requests from your machine. If you want to see the replies, just change the code to 0. This will show you now all the replies coming to your machine. If you want, you can add a destination as well if you want, trusting any specific who is sending you reply. So you can say this particular machine is sending me reply back. Okay, for the testing point of view, you can ask the server end guy or people to, are you receiving our ICMP requests? So you can ask them to, can you do this filter on your machine? So that will show them whether they are receiving any ICMP request or not. If they are receiving something, that's good. Now there are a couple of more options, you can play with it, or you can see more option if you do type this. Let's do one more option, prototype. As you know, in the OCI model or TCP/IP model, every protocol has a number. So ICMP protocol has a number that is equal to 1, and I want to see all the ICMP's protocols. Here you can see ICMP protocol is set to 1. I think if you are generating more traffic, you can check the same thing for TCP protocol, which is 6, and UDP prototype, which is 17. You can check. And if you want to check some your fragmentations bit, so here that means we are not doing any sort of fragmentation in the network. So there are lots of available options in this Wireshark you can set. So I hope you like this information. Stay tuned for more video, and thanks for watching this. Thank you very much.